So this video is going to quickly cover a few of the questions we went over in class today on Thursday, January 7th or Friday, January 8th. And below the video, I will outline where you can find the Desmos slides if you were absent and which slides you should focus on. So today's learning goal was, given a ratio table, I can describe the real world scenario and correctly fill in the missing spaces. So the first thing that we did today was a do now activity where we focused on reviewing equivalent ratios. So you might remember that the way we find equivalent ratios is by multiplying both sides of the ratio times the same number. So for example, 3 times 3 is 9 and 5 times 3 is 15, which means the ratios are equivalent. Now, students filled in this ratio by recognizing that 12 times 4 is 48. And whatever we do on the left side, we must do on the right side. So we'll also multiply 3 times 4 for a missing number of 12. In question 2, we're moving from larger numbers to smaller numbers. You can see that we need to figure out the relationship between 24 and 12. I know off the bat that 12 is half of 24, so I'm going to go ahead and write 24 divided by 2, because that equals 12. And whatever I do to the left side, I'm going to also do to the right, so I have 10 divided by 2 as well, which gives me a missing number of 5. And I can confirm that that's correct because if I move in the other direction, from small to big, I can multiply both sides of the ratio by 2, and I'll get my other ratio. Now, question 3 works in the same way. We want to figure out the relationship between 18 and 3. 18 divided by 6 is 3. Remember, we're talking about proportional relationships, so we always need to use multiplication or division. And that means we'll divide the other side by 6. 9 divided by 6 is 1.5, and you might need a calculator for a question like that since it's not a math fact or a whole number. Now, this review is going to be really helpful when we start talking about ratio tables. In our first activity, we run into a situation as follows. Noah bought 4 tacos and paid $6. At this rate, what is the cost per taco? Show your work below using both strategies. So we know that the ratio of tacos to cost is 6 to 4, and we're trying to find the cost per one. Now, I can see that the relationship between 4 and 1 can be described as 4 divided by 4 equals 1. If you get stuck on this part of the question, I just suggest that you write out 4 divided by something equals 1. To help you identify what that number is going to be. You know we're using division because we're moving from larger numbers to smaller numbers, or we're scaling down as opposed to scaling up. After we divide the right side by 4, we'll do the same thing to the left side, and we end up with an answer of 1.5. Now, you might recall when we talked about unit price, we could also think of this as simply the cost per taco. We know the cost is $6, and we know $6 gets us 4 tacos. 6 divided by 4 is, of course, $1.50 per taco. Either strategy, I'm dividing 6 by 4 for a final answer of $1.50. These are 2 ways to solve the same problem, simply laid out differently. Now, in the activity on Desmos, it says complete the table to help you solve these problems and explain or show your reasoning. Noah bought 4 tacos and he paid $6. At this rate, how many tacos could he buy for $15? On your Desmos screen, I broke this up a little bit more to step 1 and step 2. Step 1 asks you to fill in the price for 4 tacos and 1 taco. Well, we know that 4 tacos cost $6. And we know that 1 taco costs $1.50 because remember, we just found the answer to that question in the step above. Now, the second part of the question says, how many tacos could he buy for $15? Because it's asking about $15, I know that 15 belongs in the price column of my table. In order to find the missing number here, or the number of tacos I could buy for $15, I can set up an equivalent ratio. Remember that every ratio in a ratio table is equivalent. This means that I can select any one of those ratios, in this case there are only two, to use it as my known ratio, the ratio that's going to help me find my missing value. So for my known ratio, I'm going to choose 1 to 150. I know that some number to 15 has to be equivalent to 1 to 150, because if I'm going to put this ratio of something to 15 into my ratio table, it needs to be equivalent to all the other ratios in the table. So I'll just solve this like any equivalent ratio problem. 150 times 10 is 15, so I'll also multiply 1 times 10, and my missing number is simply 10. Now, later on in this unit, I'm going to ask you to come up with your own ratio that you could drop into a table. You could find that ratio by picking any one of these ratios and simply multiplying both sides by the same number. Let's say I picked 4 to 6 as my ratio, and I wanted to scale it up by 5. I would simply multiply both sides by 5, and that would tell me that 20 tacos would cost $30. I know that this is a valid entry, or it belongs in my ratio table, because I can multiply both sides of a ratio from the table to get my new ratio that I entered in the table. Now, at this point, you want to head to Desmos and complete the rest of the problems that I've outlined below this video. As always, if you have questions or need help, make sure you let me know.